Our presentation today is going to discuss preprocessors, specifically two types, HAML and SASS. What are preprocessors? Essentially, a preprocessor is a program that processes input data and outputs data that is used as an input for another program. Preprocessors are commonly used for many programming languages. Preprocessors have been in development for web markup and style languages for quite a while. Evolving with HTML and CSS, they have been gaining increasing acceptance and prominence in recent years. The idea of preprocessors for the web was a somewhat divisive topic. Proponents of preprocessors said that they were essential tools for web design and programming because they allowed functionality such as the use of variables, complex operators, and functions that were not programmed into HTML and CSS proper. Detractors of preprocessors claim that they were at best a development crutch, and at worst a kind of cheat, rather like the performance-enhancing drugs for athletes. HAML is one type of preprocessor. It stands for HTML Abstraction Markup Language. It's predominantly based on Ruby. It was created in 2006 by Hampton Catlin. It was designed as a replacement for templating languages such as PHP, ASP, and ERB. It is best thought of as a system for making templates of HTML content so that developers can avoid writing inline code, and it is because of this that HAML is sometimes referred to as a lightweight markup language. An example of inline code would be the following. In 2012, the maintenance of HAML was taken over by Norman Clark. HAML has 4 core principles. The first principle is markup should be beautiful. What this means is that the markup should be user-friendly and it should be easy to implement. The second principle of HAML is that markup should be dry. Dry stands for do not repeat yourself. HAML strives to avoid unnecessary repetition by using indentation to indicate the beginning and end of code block. The third principle is markup should be well indented. This makes the code much easier to read. The fourth principle is HTML structure should be clear. It makes code logical and easier to read, and this helps with code maintenance. One of the most attractive features of HAML is that it strips out as much of the annoying repetitiveness inherent in HTML. Elements are differentiated by indentation rather than a closing declaration. In other words, HAML is whitespace dependent, and this helps to reduce the chance of error. In HTML, every tag must have an opening and closing declaration. With HAML, tags are declared by prefixing them with a % character. Here's a more detailed example comparing HTML and HAML using tags. While this may not seem like a large change at first, this dramatically reduces the amount of markup one must perform, and further reduces the chances of errors by not requiring a closing declaration. This is a lifesaver, as anyone who has ever tried to hunt through thousands of lines of markup to find an error only to realize it was caused by forgetting to close an element. HAML simplifies and streamlines the process of denoting classes and IDs. The syntax of HAML in terms of class and ID reference is very similar to that of CSS. Just as in CSS, a period is used to denote a class, while a hashtag is used to denote an ID. Here is a detailed example of comparing declaring classes and IDs in HTML with classes and IDs in HAML. Even though HTML5 has implemented a number of awesome specialized elements, divs are still the bread and butter of web design. The sheer frequency of div usage in markup led the developers of HAML to give divs their own syntax. To declare a div, you just need to declare an ID or class. For example, Here is a more detailed example comparing div declaration in HAML with div declaration in HTML. Attributes in HAML can also be nested together, forming dependent divs for each one. The relative ease of HAML is made more apparent by the substantially fewer number of characters needed. Another thing to note is that HAML is completely compatible with all the tags present in HTML5. Commenting in HAML is relatively easy. To write a single line comment, simply type a / followed by the comment content. To write a multi-line comment, indent your commented code to be wrapped by the /. Here is an example. To write a silent comment, meaning a comment that won't be written into the document at all, use a hashtag before the comment. HAML is capable of handling inline content, but it is generally not a good idea, as we have seen in many of the above examples. Take the following HAML code for example, which once the code was compiled and processed, this would be the result. This is a far cry from what was expected, which can be seen when compared to the following. This is what we mean when we say HAML is bad for content. This is less of a criticism of the shortcomings of HAML and more of a recognition that HAML is designed for a specific purpose and styling content is not it. One should not be afraid to put plain HTML into the document. HAML has no problem distinguishing between the two. Another solution for handling content when using HAML is to use a content filter. HAML allows any block of content to be passed through a filter, which will then process the subsequent code. The following filters can be used in HAML. All of this basically reiterates the point that HAML was designed to be a templating language whose purpose is to optimize the writing of code, making it easier, faster, and more enjoyable.
The next portion of our presentation is on SASS and CSS, so the styling side of things, as opposed to the HAML and HTML markup side. But before we get into exactly what SASS is and how it functions, let's talk about what CSS itself is and what it does. So CSS stands for Cascading Style Sheets. Basically, the style sheets style the layout of markup documents. Most commonly, this is HTML, although there are a number of different types of markup, such as XHTML and others. The main benefit of having a separate styling language from your markup language is that it keeps the content of the page separate from the structure or foundation, the building blocks of that page. So let me give you an example. If you have a very large and complicated website that you're building or maintaining, the individual pages of that website may share many, if not all, of the same structural elements, such as the navigation elements, the individual containers, and so on. But the actual content of these pages differs page by page. So on one, you might have embedded video content, you might have music content, you might have static text content, whatever the case may be. Having that separate, you're able to adjust the content of the page to make changes to add or remove content without actually having to change the structure of the page. If you had a single document that had both the markup and the styling, you'd have a separate page for each individual web page. And in order to adjust anything, you'd have to hunt down the individual rules. You'd have to hunt down the styling rules within the markup and adjust them accordingly, and you'd have to do this for every single page. This would make the pages so much vastly more complicated, error-prone, and just generally awful than it is currently. So having them separated is a godsend. It makes maintaining and developing so much easier than it would otherwise be. However, styling has become more and more complicated as new differing types of content have been developed, new rules have been explicitly defined, and so on. So just like the movement for coming up with a way of reducing the complexity by being able to template the markup, the same idea was applied to the styling. In comes SASS. SASS stands for Syntactically Awesome Style Sheets. So SASS is a preprocessor just like HAML. So you'd have a SASS script, then that would be passed through an interpreter, and the plain CSS would be output. SASS was developed from the same people who did HAML, actually, interestingly. So a lot of the structure is the same, a lot of the syntax is the same, which is great. And it was also developed in Ruby, just like HAML was. And the main version of SASS that's currently maintained is still maintained in Ruby, although a number of different iterations have been developed in languages like PHP and Java and C. So a very important feature that is available in SASS that's not available in CSS are things like iteration over variables, looping, complex number functions, basically stuff that's found generally only in object-oriented languages like C and Java and so on. And you're able to do similar things in SASS, which is really amazing. It enables you to do much more things with styling than you would otherwise be able to do. Things that you would typically need embedded code like JavaScript or something like that, you can actually do with just your CSS by using a preprocessor. The syntax of SASS is very similar to HAML, namely it uses strict indentation rather than actual characters to delineate code blocks and individual rules. So whereas with regular CSS, a code block is delineated by bracketing and rules are separated by semicolons. In SASS, you have nesting. You have indentation that defines everything, which is great because it reduces the number of characters needed, and it also makes writing a styling page very similar to writing your markup page, because both of them use indentation in much the same way. This is no surprise given that they were developed by the same people and one came out of the project of the other. All right, so the first feature that's of note in SASS that's very useful is variables, the use of variables and the ability to reuse them to store styling rules and then have individual calls for them in the document by individual elements. In order to declare a variable, it's very simple. All you do is you preface the declaration with the $ symbol, and then you write out whatever declaration, whatever variable that you're referring to. So let's look at an example. In this one, we have a font stack variable that sets the type of font. So in this instance, Helvetica and sans serif. And then we have a color variable declaration. Now the color, just like in CSS, there's different ways of doing it. You can actually name the color like red or whatever, or you can use a hex value, an abbreviated hex value like we have here. So then next in this example, we have the body element, and then we have a font declaration, which we declare in an individual instance the size of the font, but we refer to the general declared rule above to set the type of font. And then we also did the color of the body font in the same manner by declaring that by referring to that previously declared variable. Okay, so here is the output of once the SAS script is passed through the interpreter. This is the CSS. So you can see that rather than having externally declared variables within the CSS, each rule is declared in every instance. So here we have within the body element, we have the font declaration, so the font size and then the font type and then the color of it. And for every element, these rules will be declared individually. So it's a lot simpler in SASS. You know, that might not be entirely evident given the brevity of this example, but if you have a 1,000-line style sheet in which you call the same basic rules, you know, over and over and over again, the ability to externally set these variables and then just call them throughout the document makes things drastically simpler. Another feature we briefly mentioned earlier was that nesting hierarchy in SASS. This is very similar again to HTML, which makes writing them easy in that you don't have to switch gears between the differing syntaxes. CSS does not have clearly defined nesting hierarchies. All of it is performed in terms of bracketing. So let's look at an example. Here we have a container class. Within that container class, we're defining its border radius. So this just defines the curve of the border, and then we're setting it as a solid border with a particular color here. This I think is gray. And then under that, within that a child list, we then style that list or not, is no style particularly in this instance. And then we style the list instances, the list items as a floating right declaration. Here in the CSS is the output. As you can see, we have the container call. So this doesn't differ that much from the SASS, but then you can see that the subsequent elements, in order to refer to the parent container, you have to call the container class and then list the individual element. And then you have to do that again with the list element if you want to maintain the same styling rules that are within that container class. A further example illustrating the fact that you can nest properties is the following. So here we have a declaration of a div container, just a general purpose container. Within that, we have a general font declaration, and then we have the individual elements of the font declaration. So we have the font family, the different font types, the style, which is italicized in this instance, and the weight, which is normal, so it's not bold. And then here is the actual CSS output. So as you can see, we have the div element, and within that, you have to refer to the font family, then font style, and then font weight. So instead of being able to just refer to font generally, and then the individual rules of the font, we have to refer to font, the font with the actual rule every single time. All right. What might be the most important feature available in SASS, at least in my opinion, is the ability to perform looping. This is amazing. It enables you to do so many things that you wouldn't otherwise be able to do with CSS. This is typically available only in object-oriented languages, as we mentioned above. So the main functions for looping that are available in SASS are the for, each, and while functions. In order to declare a function, all you have to do is place an @ symbol before the declaration. So @for, @each, and @while. Basically, functions can apply styles to elements with similar classes or IDs. So let's look at an example. So here we have a SASS instance. We're going to iterate a square count function 3 times. So for every iteration from 1 to the number of square count, which we declared was 3, we're going to do the following. We're going to set the background color to red. We're going to set the width starting at 50 times the number iteration we're on. And then we're going to set the height from 120 pixels originally to, or divided by the number of iterations. So the output would be thus. For the first iteration, for the CSS, we'd have a container, the first square, which would be colored red. It starts again at 50 pixels for the width and 120 pixels for the height. The second iteration, where the actual calculations are being performed listed in the for loop function, show up. So we have, again, the color red that doesn't change. Then we have the width, which is the original 50 multiplied by the number of iterations, which in this case is 2. So we have 100 pixels here, and then the height, which is the 120 originally divided by the number of iterations, which again is 2. So we have 60 pixels for the height. Now the third one, again, we have red. The width is 50 pixels times the number of iterations. So now we have 50 times 3, which is 150 pixels, and then the height would be 120 divided by, or sorry, 60 divided by the number of iterations, so now we're at 20 pixels. All right, the next very important feature available in SASS is the ability to use mix-ins. So mix-ins are identified just like they would be for the looping rules, with an @ symbol followed by the mix-in rule, and then any subsequent style calls that are outlined in that rule. So let's add an example of this. Here we have a button call, a mix-in button. We have a color declaration argument and then a color hover argument. So we're setting the color to color hover, whatever that color is. And then we have, whenever the button is hovered over, it sets that color to the color hover, whatever that is. All right, so then we have the class of button called, and then within that we have the actual color set. And then the output of the CSS would be, we have a button which has a color specifically defined, and then we have a hover event, a pseudo selector of the button where the color is then changed. Now that can also be changed to where you have an original color set at the beginning, which is then overwritten. So you're able to do a few more things. It's pretty flexible. Finally, the feature that we discuss here that's very important is the ability to do fairly complex numerical functions and equations. Now this SASS features all of the arithmetical operations of addition, multiplication, subtraction, division, greater than, less than, or equal to, and combinations therein. But it also has unique ability that's not available in CSS with the following functions. So we have a percentage function that takes a value, turns a value into a percentage, the round function, which rounds a value to the closest whole number, the ceiling function, which rounds a value to the up to the nearest whole number, the floor function, which rounds down to the nearest whole number, and the absolute value function, which obviously finds the absolute value of a function. So let's look at some examples of this. All right, so we have the height. We have a percentage of 150. We have for the width, we have a rounding of 3.6 pixels. We have a border radius with a ceiling of 21.3 pixels, ceiling function, a height of a floor function of 2.6 pixels, and a width of the absolute value of -8 pixels. So the output in CSS would be the following: the height of 150%, a width of 4 pixels, so we're rounding up in this instance, a border radius of 22 pixels, so again, it's rounding up even though it's closer, the closest whole number would be 21, but because it's a ceiling function, it rounds to the closest number above it. The floor function of 2 pixels because it rounds down, and the 8 pixel width because it is an absolute value, so it negates, or it removes the negation there. So in conclusion, I've used precompilers for a number of years, and I can honestly say that they are amazing. They save an inordinate amount of time, especially in more complex pages. They're very useful in making templates and sort of building blocks that you can just refer to rather than have to call out these individual elements over and over and over again. It makes editing and changing documents really, really easy to hunting through and finding individual elements. It's substantially simpler, but they're not perfect. They can't do everything, as we mentioned in the case of HAML. you cannot style content, or sorry, you can style content, but you shouldn't style content in it because it comes out not nearly every time completely different from what you're intending. And on SASS, the actual indentation rules are very, very restrictive. I mean, this problem was remedied in some of the subsequent projects, pre-compiling projects, and it is a lot better. I typically use SCSS when I'm developing web pages. I love it. But the ability to actually style in CSS and to markup in HTML will never go away. There's some things that you just can't really do in the actual pre-compiled language any easier than you could do in the plain version, the plain format. So that will always be there. And I can say that most of the problems that people attribute to the precompilers can be attributed to basically that they're purpose-built tools. You're not going to use a hammer to perform, delicate brain surgery. So why would you use a HAML to do content? If you use the tools for what they're intended for, then they're very, very useful and invaluable. Thank you.